Alright, so I have PyCharm already open. I'm just going to go ahead and create a new program. And we're just going to call it Caesar for the Caesar shift. And we're going to make a new file. And we'll call it Caesar. And there we go. And I'm going to start out with comments, because I always do. And we'll call this a Caesar Cipher program. And we're going to specify that we're using a for loop. And we're going to put a byline in there. Now whether or not you choose to is up to you. So we're going to do creating variables here. And this will be running the for loop. And this will be printing the results. So the variables that I'm going to need: original message, so we'll just call that message. And for right now, we're going to use the same one that we were using earlier when I talked about ciphers in general, and also when we talked about kind of what this would look like. We're also going to need a shift value, so how much are we shifting this by? I'm going to start with 1 just for simplicity. And then we also need the encrypted message. And for right now, this is just going to be an empty string. As our program is taking this and converting it letter by letter, it's going to be adding it to this empty string, so the string won't be empty anymore. It's going to get larger and larger until it goes through all the characters, and then that's what it'll be. Now we're going to use a for loop, but before that, I'll go ahead and put the ending on here, and that's going to be prints the encrypted message. And now for the for loop. So we're going to do for character in message, which is pretty much what we'd done, or it is what we did in the previous video with the mirror writing. Now this message, this is not a special word, this is this variable, so they have to match. If I were to change this to user message, then I would need this to be changed as well, because right now this underline shows me that it's not connected to anything. So it doesn't really matter what you want to call your variable, but they need to match. So the way that this is going to work is it's going to go through each one, and it's going to add the shift value to it. So I'm just going to use the variable x to represent each character. So x is going to equal the character, and then x is going to be itself plus the shift value, and then the encrypted message is going to be itself plus x. If I did character, it would have completely defeated the purpose, because this conversion here, this adding the shift value, would have been done for nothing, because it would go back to that starting character. So this needs to be x. Now right now this isn't going to work for a couple reasons. One, that we're trying to add an integer right here to a string. Now it might be a string of 1 letter, but it's still trying to concatenate those together, and that's not going to work. So we need to use the ord and the char commands that we talked about in the previous video. So if we put ord in front of this, it's going to convert character into the equivalent number that's tied to this method. It's basically an ASCII type number. Now when we do the encrypted message, we don't want this x anymore, because it's going to be a number with 1 added to it. We're not looking for numbers, we're looking for letters, right? So that means we need to go back to the equivalent letter. So char is the opposite. So we're just going to ask for char. Now if we do this right now, it'll basically work. If we tell it to run, we have code here. And it looks decent. Couple issues though. It's converted the punctuation as well. And it's converted the spaces into punctuation. So that's not quite ideal. And this is with the shift value of 1. So if we do like something larger, like 20, and we run it, now we get something that doesn't match up at all and doesn't work. So the reason why is once it gets beyond z, it's going to other characters and symbols, and it eventually just ends up at a whole bunch of weird spaces and whatnot. And we don't want to have to like limit our shift value, because that doesn't make sense. It should be going back around to a when it passes z, right? But that means we need to tell the program to do that. Now to do this, that means we also need to know what these values are. we're only converting them into letters, so we don't know what the values are. So we don't know what sort of math we can do to prevent it from going over whatever the value of z is. So I'm going to go ahead and just add a comment sign to this right now, just to tell it to not print anything out. And I want to see what are the values of a and what are the values of z. And I forgot to put quotes around them. And I forgot to print them. There we go. 97 and 122. So A is 97, Z is 122, and all the other letters are in between. So B would be 98, C would be 99, etc. So that means basically everything needs to be brought down by 97 values. And we can do that if we go ahead and delete this, and we go ahead and subtract this by 97, and then we run it. We're going to get something weird. Two things. Just because the ORed value of A was 97 doesn't mean the ORed value of everything else was above 97. The issue that we had here was actually the punctuation. So if we do ORed of a space, that's a 32. So minus 97, not so great. Exclamation point, 33. Also problematic. And a period, also below 97, so problem. So not only do we need to do minus 97, we also need to make sure that it's only doing this for the alpha characters, not punctuation, not spaces. So I'm also going to do if the character dot is alpha, so it's going to check if it's an alpha character. If that is equal to true, then we're going to do all of this stuff right here. Otherwise, or else, we're just going to add that character to the encrypted message. And we're going to do that because we still want the space, we still want the exclamation point, we just don't want it to convert them. Well, you might not. You can decide what you want for your code. But I still want them anyway. So now if I try running this, it's still complaining because I still have values that are below 97. And you might be saying, what values? And don't forget, we have capitals in here. And these are alpha characters, but a lowercase t and a capital T are not the same. So if we do print ORed capital A, and we do print ORed capital Z, and we run this, we can see that both of these are below that 97. So 65 to 90 are capitals. So that's also an issue. Now we have two choices. We could have another if here, where it's running one for capital letters and a different one for lowercase letters, or we can just convert the whole thing for lowercase letters. And I'm going to go ahead and do that just for the interest of time. So user message equals user message dot lower. So now if we run this, it should be okay. There we go. No freaking out. Now this isn't very useful, right? Where are all the characters? And that's because we subtracted 97, but we never put it back. So we need to put 97 back. If we do it to one side of the equation, we need to do it to the other side of the equation. Now if we run it, that looks better. Exclamation point, period, spaces, these letters look fine. However, we haven't fixed anything for that wraparound, right? So if it goes beyond Z, what happens? Right now, not a big deal. Nothing's beyond Z, but we don't have a Z in here. We do have these Y's, though. So if we increase this to 2, and we run it, y now becomes a curly brace. It didn't wrap around to a. And if we do something extreme with this, like plus 20, well, now we have a whole bunch of nothing useful. So it needs to pay attention to what happens if it goes outside of those bounds, if it goes beyond the, I believe it was 122. So we could try to write some complex if for that as well, but we don't actually have to. In this point right here, nothing is above 25, 26 because of this subtraction. So what we can actually do is we can use that modulo function that I mentioned earlier. So if we do x equals x mod 25, now what's going to happen is if this value is divisible by 25, it will then only produce the remainder. Now that might sound kind of confusing, but basically what happens is, like, we know that a equals 0, right? And we know that z equals 25. We know that y equals 24. But when you add 20 to it, then z is no longer 25. Z is now 45. But you still need it to be within the range of 0 to 25. It needs to go back to the start. And we could use an if value for that, but instead we could just use modulo instead. So in the event that z has 20 added to it, we end up with 25 plus 20, which equals 45. That's way too high. When we do the modulo to it, what will happen is it will be able to fit 25 in here once, and it will basically just subtract 25 from that. So that ends up equaling 20. If this were a different letter, like maybe G, let's see, G is 7, which if we start counting at 0, that becomes 6. So 6 plus 20, that becomes 26, which mod 25 would become 1, right? So it becomes the remainder. So that will keep it within the bounds. Now, of course, we could have done this with subtraction, but we would have needed an if value to check if it was above 25, and then subtract only if it was above 25, and then you would need an else to not subtract, just to run it the way it was if it was below 25. And that's a couple extra lines that we don't need. So doing this right here will work. And there we go. And now no matter what value I put here, whether it's a 1 or a 15 or 155, we'll still be good. There can be a catch here. If we do like 150, for example, and we do run Caesar, we get right back our original result, and that's actually because 150 is divisible by 25, and so it puts it right back at the original string. If we do 151, it'll go over. If we do 149, it'll be 1 under. Because keep in mind, out of all the possible combinations, it's going to eventually come back to itself if you choose a bad shift. Of course, you should never be choosing anything that high anyways. You know what? Actually, I think this is supposed to be 26, because now that I think about it, let's see what happens. There we go. That's the same. If we do 25, that becomes x, x, y, z. If we do 27, x, y, z, good, good. Yeah, when we do 25, we actually end up missing one of the possible combinations. So make that 26. And now we should be good. Now you have a nice little Caesar cipher program using modulo, using the for loop, and where we can quickly and easily change the shift value to whatever we want without having to change 26 lines of code. It's slightly more complex in the way it works. It's a little bit more elegant. It takes a little bit more understanding and learning, but the result is a better program. So even though this is the method that I chose to use, as always, it's not the only method, and I'm not going to argue that it's the best method. It's a decent method for what we've covered so far, but of course, depending on what you want to do, how you want to do it, what it's for, there might be better methods. Now in this method, as I stated earlier, we're only using lowercase, so everything ends up being kicked out in lowercase. If we wanted it to be case sensitive, if we wanted the capitals to stay capital, then we might use something that looks more like this, where we're checking inside of this for loop whether or not the character is lower, and if so, doing this, and if it's not lower, then it must be capital, so then we're doing that. Of course, you might say, well, what about the punctuation? Well, I already had that covered up here with the is alpha. If it's not an alpha character, then it gets kicked out as itself, which would be your space, your punctuation, any other weird characters that might be included. Which is also nice too, because then if you end up having some strange character, hopefully it won't break the character, because it should just check as false and then print it out the way it is. Once again, this isn't necessarily the best method, it's just a method. So looking around a little bit, I found this method, or something very similar to this method, that I worked from and built up from, which was actually a post on Reddit from about a year ago. And so it talked about how to do a case-sensitive Caesar shift without using conditional, which I thought was an interesting idea. So instead of using sort of the alphabet twice in both lower or upper, or shifting them separately depending on which one it is, it used the string of the alphabet as each character with capitals and lower cases. And so it's going to check where the index of the current letter is for each letter, and it's going to multiply the key by 2 to then figure out where it should go. So if it's a shift of 1 and we're at a lowercase a, instead of shifting over just 1, it's going to multiply it by 2 and shift over 1, 2. So we end up with the lowercase b. So it's still a shift of 1 for lowercase. If it were a capital A, instead of shifting over to a lowercase a for 1, it's going to have that multiplied by 2, and it's going to move over to a capital B. So I thought this was a pretty clever way of doing it as well. Now, once again, whether or not this is the best method, that's up to you to decide. Let's just make that a little bit more accurate. Now, that was only part of the program that he had listed there, so I had to play with it a little bit to decide how I wanted to do it. But once again, I mean, you can play with this and decide what works for you. This might be a little too advanced, depending on how far you are through Python and how much you know about programming already, and that's okay. It's just to show that there are a variety of ways that you can do everything, and you shouldn't ever think that this is the only possible way to do something, because it's probably not.